Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies, and welcome to this episode of Dan's Vehicle Dynamics Corner. This episode of Dan's Vehicle Dynamics Corner I'm really excited about because we're going to be talking to you about a new feature that's just been released with ChassisSim version 3.16, which basically is going to give you the ability to reverse engineer engine curves using ChassisSim. This is a topic I've sort of covered on the peripheries in some of my race car articles, and it's been one of these things that up until recently, I really haven't had to sort of treat in anger. But the reason I've had to treat it in anger is I've had a number of my clientele come up to me where they've actually had they've actually had their engine builders not play very nice in terms of producing an in terms of producing an RPM versus horsepower curve. Personally, I think this is a very, very sad state of affairs because, quite frankly, you can look at engine power curves until you're blue in the face, but the real skill is not necessarily what those engine power curves are. The real skill is how to create it. That being said, believe it or not, actually reverse engineering those curves is not as difficult as what you're going to think. And that's what we're going to be talking about in this particular tutorial. Now, the reason this might arise is that historically, engine builders do tend to be incredibly paranoid about showing their hands in terms of in terms of what their engine power or engine torque versus RPM looks like. But sometimes they're also trying to force you, particularly for the bigger corporate organizations, they're also trying to force you into the tools that they're using. Now, I've always said that this is a thinking man's business, and believe it or not, you can actually get a fair bit down the road by actually just using a bit of common sense and a bit of intelligence. So what we're going to talk about in this tutorial is how we'll go about attacking it. How we're going to use ChassisSim to reverse engineer, how we're going to use that new feature in ChassisSim version 3.16 to reverse engineer it, and then we're going to show you how to piece it all together. And I think you're going to find it's actually going to be a lot more straightforward than you think. So, what we're going to need to start, you're going to need to get a rough idea of max horsepower. Now, this doesn't need to be accurate to about a tenth of a kilowatt. It just has to be within about, a couple of kilowatts or a couple of horsepower. Something to give you an idea of a rough yardstick to say, this is what we're going to need. Because let's face it, most engine manufacturers or most horsepower most engine manufacturers are going to give you some sort of idea, if only for bragging rights. The other thing that you need is you need data from the longest straight with the car balance. And as you can see where I've placed the cursor, you can see I've basically placed it down where the car is basically perfectly balanced, where it's not accelerating anymore. We're taking a look so that should basically give us a rough idea of how to calculate the drag. So basically, to calculate the drag, CDA is effectively a gear ratio times the engine torque divided by the rolling tire radius, subtracted from the mass of the car, times the acceleration due to gravity times AX, presuming we're measuring AX in terms of G, divided by a half rho V squared. So what we're going to do is just going to walk through a simple F3 sample calculation. So here we've got the power at 150 kilowatts, we've got RPM at 6,500, the rolling tire radius is 0.28 of a meter, the speed is 220 kilometers per hour, our gear ratio value is 3, and our mass of the car is 500 kilos. So, as you can see, what we're going to do is walk you through a sample calculation. Now, our first point is we need to calculate out what the engine torque is, and that is as easy as it's simply 60 times engine horsepower in watts divided by 2 pi RPM. That's all it is. So as you can see for our numbers, it's 60 times 150 times 1,000 divided by 2 pi on 6,500, which is 220 Newton meters worth of torque. Now that we've got that and we've got a driveline efficiency of 90%, we simply use the equation we had earlier and we plug in the numbers. So we've got gear ratio times the torque, which is going to be 200 newtons per meter. So that's 220 multiplied by 0.9 divided by the rolling tire radius minus mtg on AX divided by a half rho V squared. Now remember, V is in meters per second, so we need to convert kilometers per hour to meters per second, so we simply divide by 3.6, and so we just simply walk through the numbers as we do there, and CDA of 0.937. That's it, boys and girls. It's as simple as that. It is high school maths. There's no rocket science in here. Now that we've got that, we've got our CDA. What we can do is that we now apply that to ChassisSim. Let me just show you how you'd apply. Let me just show you how you'd apply that, and let me go into let me just go into ChassisSim. So here, I've loaded a sample car file, and all I would do here is there are a number of ways you can do it. If you've got an existing ride height sensitivity map, what you do is you just simply click on here and you highlight CDA, and you basically plug in the number we just calculated, which is 0.937. Now, you can either do this and you can scale it to a ride height sensitivity map that you've been provided with, or alternatively, what you can do is that you can go into your downforce, drag, and aero balance quick start here, and simply click on OK. And what that will do is that will basically set the drag constant everywhere. So there are two options that you have at your disposal. Personally, as a rough rule of thumb, it depends. If you think that the trends are roughly in the right area, by all means, you can use ride height sensitivity aero maps that have been provided by the race car manufacturer. But if you want to keep it simple, I'd use a aero balance circuit. I would use the a fixed aero balance. Whatever you do, it's up. Whatever you do is up to you. Now, going back, as we can see, we then basically, once we've got this, we basically need to export out a monster file from our single flying lap, and we open up the aero toolbox. And as you can see here, I've basically got my aero toolbox open. Now, the critical thing here is that you'll see that I've clicked on the tick box that says click here to generate engine curve, and all I need to do is press OK. And when we're done, a file called aero_eng_power.dat is going to be created in the same directory our car file is. Let's walk you through an example of how to do that. So I click on ChassisSim, and I simply go to Simulate, generate, go to aero modeling, and here is my so here is our aero modeling. So obviously I've zeroed my dampers on the deck. I'm going to use my downforce, drag, and aero balance tolerance as I would if I'm running an aero balance, as if I'm running a standard aero toolbox run. I simply click here to add my monster import file, and all I've got to do now is click on one, click on OK, and that's it. Aero analysis results done. And what that has done is it's generated this little file here called aeroenginepower.dat. Now, all this is just simply an ASCII text file that I'm just going to simply open up a notepad. And as you can see, we've got RPM here, and we've got engine horsepower, in kilowatts here. So what we now need to do, the next step in the process is, now that we've done that, what we now do is that we now go back to we now open this up in Excel, and you'll get a curve that looks like this. Now, the nature of that curve is such that there is going to be noise in there, and for this I make absolutely zero apologies for. This is the nature of when you're looking at circuit data. It's not going to be perfect, and quite frankly, ladies and gentlemen, if you are looking for perfection, you have come to the wrong business. But what we need to do here is we do basically an engine curve fit. And once we've got the engine curve fit, we basically apply this to the ChassisSim engine curve by clicking on the engine power. Now, it would have been very, very easy for me in the process of this to simply punch out an engine power curve that you could just basically import straight in. The reason I've done this is so that you as the user can basically go through and make some sensible determinations in terms of, well, hang on, is this basically what the engine is going to be? So you've got some sort of range of what to look for. This is something I make absolutely zero apologies for, because I've said this before and I'll say it again. This is a thinking man's business. And quite frankly, I've said on a number of occasions, one of the things that is very much disturbing me about this business is the tendency of software providers to dumb down this business. Well, quite frankly, if you want to have this dumbed down, then I had to say it, OPB, other professions beckon. That being said, if you do the work, look at this sensibly, that's the sort of correlation that you should be expecting. Now, on this curve, the top curve is speed. The second curve is throttle. We've got engine RPM, and we've got basically our longitude, and we've got our longitudinal acceleration. That once you've got something like that, you've got something that you can basically do gear ratios with and start to use it for sensible performance evaluation. Is this perfect? No, it isn't. As I said before, if you are looking for perfection, you've come to the wrong business. That being said, what you've now got something that you can engineer the car with, and that, ladies and gentlemen, is something very very powerful. So, what I'd encourage you to do is for existing ChassisSim users, have a play with this. If you're not an existing ChassisSim user, by all means, send us an email, request a download, and we can get you going so you can try this out for yourself.